Alright, in this video we're going to be using rational exponents, which are the fractions and exponents, but then also incorporating negatives in them as well. So hopefully you remember that a negative exponent reciprocates. So negative in the exponent is a reciprocal, and a fraction in the exponent is a root. Or a radical. So just to start, if I put a negative in an exponent, it means 1 over. That's what I mean by reciprocal. So it could move something that a factor in the top of a fraction into the bottom, or likewise, if we had a negative exponent in the denominator, it would flip to the top. So let's try some of these and just make sure we're sort of getting these negative exponents. The first thing I'm going to do in all these is deal with the negative. So first step in part A here is to say this is 1 over 8 to the 2/3. But that's what that negative does. And notice once I reciprocate right as a fraction, now I don't have a negative exponent in there anymore. I dealt with the negative by doing the reciprocal. The next thing we want to deal with is the 1/3, right? That rational exponent, the fractions in an exponent is a root. So this divided by 3 in the exponent is actually a cube root. So I'm going to rewrite it that way as the cube root of 8 squared. And in the last video we talked about how you could do the squaring first, but the numbers are smaller if you do the root first and then squared. The cube root of 8 is 2. So now I have 1 over 2 squared, which is 1/4. So the answer to part A is 1/4. All right, let's try another one where we're multiplying. Because these have different bases, we can't combine them into one, but I can deal with this negative exponent. So the negative exponent is going to make this a fraction, and I didn't leave myself enough space, so I'm going to actually move it over to the side here. Just do part B over here. So first thing we have is x to the 1/5, and then the negative exponent makes this factor go in the denominator, 9 to the 3/2. The other factor had a positive exponent, so it stays in the top of the fraction. X to the 1/5 is, well, it's just a 5th root, and we can leave it as that. The directions didn't say write it as a radical, so I'm okay leaving it as the 1/5. But it did say simplify, and 9 to the 3/2 can be simplified. So let's keep going with this. I'm going to leave the top as x to the 1/5, but the bottom, the divided by 2 in the exponent, is a square root. So it's the square root of 9, and then the 3 in the top makes it cubed after we do the square root. So it's x to the 1/5 over 3 cubed, which is the 5th root of x, or x to the 1/5 over 27. All right. Last one. This one's a little different because the whole thing is to a negative exponent. So what that means is that the whole fraction reciprocates, meaning we're going to flip it upside down. So what I'm going to get is I'm making it a positive exponent by doing this, right? So the whole idea is I'm dealing with this negative sign, and I'm going to reciprocate what's inside the parentheses, meaning flip over the fraction. So what's in the top of the fraction goes to the bottom, and what's on the bottom goes to the top. That's what a negative exponent does. So now that I've dealt with the negative part, I feel like this is all simplified. It says write an equivalent expression with positive exponents. I got a positive exponent now. Simplify if possible, but I don't know the 4th root of 2 or the 4th root of 3, and nothing simplifies, so I think we're done. So let's combine all these things. So now that we have negatives in exponents and fractions in exponents, we can combine all these with the laws of exponents that we've already learned. So here's the laws of exponents, just to recap. We have 4 of them. So if the bases match and we're multiplying, we add the exponents. If the bases match and we're dividing, we subtract the exponents. This is one that is going to come up a bunch with the roots. So let's sort of dive deeper into this one. It says, if I have 2 factors raised to the same power, I can split it up. What that looks like as roots, let's just say it's the square root of a times b. This is the same rule that says this would be the square root of a times square root of b. We talked about this as a property of radicals, but now that we know that these radicals are exponents, this is the same thing as saying a times b to the 1/2 power is a to the 1/2 b to the 1/2. Right? Because the 1/2 exponent is the same as the square root. And we could, of course, do this with cube roots with the 1/3 power. Let's do an example where we're dividing. So if I had, and I'll do a cube root this time, the cube root of a divided by b, this would be the same as the cube root of a divided by the cube root of b. And it just depends what we're trying to do, of whether we want to I don't know, write it on the left side or the right side. So we might start with a problem like this, and it might actually simplify if we think of it as a division problem first. Other times we might start with it like on the left side, and if they ask us to rationalize the denominator, for example, we would need to split up the numerator and denominator. So there are reasons why we go in both directions, but this is the same as just an exponent rule. Saying we're raised to the 1/3 power is the same as a to the 1/3 over b to the 1/3, because the 1/3 power is the cube root. So all of our rules of exponents work with radicals. So let's try some examples of what this might look like in our homework. It says, use the law of exponents to simplify. So here I'm seeing the bases match, and we're multiplying. So that means I can add the exponents. So 7 to the 2/5 plus 1/5. And they were nice to us. These exponents that we're adding are both 5th roots. They both have that same denominator. So it's easy to add them because they have that same denominator. So 7 to the 3/5 power. Now we might also want to check, like, do I know the 5th root of 7? But I don't. So it doesn't have a nice simplified version. So this is it. This next one, notice I have same bases, m and m, and I'm dividing. So in this one we would subtract the exponents. So it's m to the 1/2 minus 1/4. Now, because we're dealing with fractions and subtraction, now we need a common denominator. 1/2 is the same as 2/4, and 2/4 minus 1/4 is m to the 1/4. And we could also write this, I just want to also remind us that that is the same thing as saying the 4th root of m. Right? M to the 1/4 is the same as the 4th root of m. All right, in C, we're going to be using the exponent rule that we're talking about up here, where I have more than one factor being raised to the same power. So notice the bases aren't matching, but they're both being raised to the 3/4 power. I'm deciding whether to deal with that negative first. I always like dealing with negative exponents as the first step, so I think I'm going to do that actually, because I don't want to miss that negative and mess this up. So first thing I want to do is reciprocate just the factor that has the negative exponent. All right, x to the 1/2, that's a positive exponent, it stays on the top. But the factor with the negative exponent is the one that goes in the bottom. So now I'm going to write this one out because there's a lot of things going on in here. That 3/4 power can be applied to both the top and the bottom separately. And I want to remind us here, because I'm sort of a little messy in how I'm writing this. These are not being multiplied by y, right? Y is being raised to these exponents. So make sure these don't look like y times 1/3, right? It should be that 1/3 looks like it's an exponent. It's a little higher, but yeah, my writing is getting a little messy, so hopefully you can correct that on yours. All right, let's keep going though. So now we have to use another exponent rule, this one up here, where if I have a base being raised to an exponent and then another exponent, we multiply those exponents. So in the top of the fraction, it's x to the 1/2 times 3/4. And in the bottom, it's going to be y to the 1/3 times 3/4. Now in multiplying fractions, we're doing all kinds of fraction review here too. We had to add fractions, get common denominators, now we're multiplying fractions. Multiplying is easier, you just go across the top, across the bottom. So on the top it's going to be x to the 3/8 power. But on the bottom, in the denominator, I'm seeing y to the 1/3 times 3/4. Those 3's cancel. So what I end up getting is y to the 1/4. Now, if you had not cross-canceled first and gotten 3/12, that would be fine, but then you should simplify 3/12 to 1/4 in the final answer. Phew, all right, that one was pretty difficult. Let's see what these other kinds of problems look like. It says, use rational exponents to simplify. So one nice thing is that roots often look pretty complicated, but if we write them as exponents, sometimes the rules of exponents are just easier to use, and then it's easier to simplify. And then the directions say, but at the end we should convert back to radical notation. So let's see what this is like. So what it's asking us to do is take this 3x quantity squared, but then the fourth root is the 1/4 power. So I'm taking 3x and squaring it and taking it to the 1/4 power. But the rule we just used up here says that we just multiply those exponents. So this would be 3x to the 2 times 1/4. And it might help to write it 2/1, because this is another where we can cross cancel and say that this is just going to end up being 1/2. But 2/4, of course, is the same as 1/2. So what I end up getting is 3x to the 1/2. And the directions say back to radical notation, and the 1/2 power is the square root. This is actually a property. Anytime I square a fourth root, it ends up being a square root, because the way the squaring and the 1/4 interact. All right, let's try the next one. So I have the cube root and to the 9th power. So I'm going to just write it out first as exponents. X, y squared, z to the 1/3 power. Not the 1/2 on this one. And then to the 9th power. Means I'm multiplying by 9/1. So what ends up happening, again, if I cross cancel, I end up just getting that this is cubed. So x, y squared, z, the whole thing cubed. Hopefully we see that, right? Because 1/3 times 9 is 3. Well, this isn't a radical anymore. I don't have a fraction left in the exponent, but I can still use properties of exponents to say, well, I can cube all these, because it's really just x being cubed, because x times x times x. Y squared being cubed makes y to the 6th, and then z cubed. So that makes it a little more simplified at the end. Well, here's something we definitely haven't seen before, is a square root inside of a fourth root. This doesn't really happen all that often, and it's because immediately we can simplify this if it were to happen. So the way to write this, to simplify, is the square root is the 1/2 power, so that's what's inside of the fourth root, or the 1/4 power. And now that I've written it like this, I can use that exponent rule that says I should multiply the exponents. So it's y to the 1/2 times 1/4, which is y to the 1/8 power. But directions wanted radical notation, so my final answer should be that it's the 8th root of y. We don't often go to the 8th roots, but that's what happens if you combine a 4th root and a square root. It turns into an 8th root. All right, last set of examples on this page. Simplify the following expressions. So in all these, we have some radicals. And I want us to use those properties that I wrote up here, where a lot of these are fractions. We can do the division first and then take cube roots, or we can view them separately. So in part A, even though it's square roots, it works the same way. Instead of viewing these as two separate things to simplify, I want to instead think about this as 48 divided by 3, and then I'll take the square root. Oops, sorry, my focus isn't working. There it is. Move this down. 48 divided by 3 is 16. And now, oh, square root of 16, that's just 4. Now you could have gotten this same answer by simplifying the square root of 48, right? Looking for perfect squares that go in there and then seeing what simplifies and cancels. But it's just a lot easier if 3 goes into 48 to do that part first. So we want to look for the easiest way, not necessarily, just what happens first. All right, so same thing here. I'm seeing a cube root and a cube root. It'd probably be easier if I think of these as one big fraction. The only thing that's sort of messing me up, though, is this 2 on the outside. But that is just a 1/2. I know it's a 1/2 instead of a 2 because it's a 2 in the denominator. Okay, so we can pretend there's an imaginary 1 being multiplied on the top of the fraction, if that helps you see the 1/2 as well. So then I'm going to view this as one big cube root to simplify, with 24x to the 4th, y to the 5th in the top, and the denominator is just 3x. So I'm still keeping that 1/2 out in front, and hopefully we'll work it back into the problem by the end. But right now I want to focus on simplifying what's inside the cube root. 24 divided by 3 is 8. So cube root of 8. And then x to the 4th divided by x, if I have the same base, we just subtract the exponents. And if it helps, you can write x to the 1st power there. So x to the 4th divided by x to the 1st is x cubed. And y to the 5th doesn't have anyone to simplify with, so we'll just keep it y to the 5th. And then we gotta ask ourselves, well, what's left in the bottom of this fraction? And it turns out it's nothing. But it's not a 0. You can either leave a 1 in the denominator or just leave it as not a fraction anymore, right? It'd be fine if you didn't write it as a fraction. Okay. So now I simplified the fraction. I got the 1/2 out there. Let me put it back together as one thing. So the 2 is going to go in the bottom of the fraction. And now I'm going to view these as 3 separate cube roots. Let me scroll back up here. So just like sometimes if 2 things are separate, we might want to put them together. Sometimes when factors are together, we might want to split them up. And that's what we're going to be doing here. Or at least that's how I'm going to go about it. There's more than one way to simplify. I'm just trying to do it the easiest way for me. So cube root of 8, cube root of x cubed, times the cube root of y to the 5th. All right, so instead of viewing it as a cube root of all these things, and I'm not worried about the 1 anymore, because dividing by 1 doesn't change it, now I have 3 separate cube roots. All right, we're getting closer. Cube root of 8 is 2. Cube root of x cubed is x. Well, then there's the cube root of y to the 5th. That, it sort of depends how we want to simplify it. I think I'm going to use our new way of writing this with rational exponents and write it as y to the 5/3. So remember, the exponent goes on the top, the root part is always the bottom, over 2. One last step, which is that the 2's are going to cancel. We have a 2 in the top, 2 in the bottom. So our final answer is x y to the 5/3. Notice when I write it this way, the x is not being raised to the 5/3. It's just the y. I would need parentheses if I want the x to be part of that exponent, but I don't. Just making sure that that's clear. One last problem. This time 4th roots. Well, I want to put these all together. Since the roots match, I can say it's the 4th root of the whole thing. So x times 5 in the top, 3 times z in the bottom. All right, that's 2 separate 4th roots. If 2 factors are both being raised to the 4th root, we can combine them. Now, if one of these was a cube root and the other a 4th root, I could not do that. We have to have the exponents or the radicals matching in order to combine them like this. Same with these fractions here. Well, really, that's simplified. The only thing I might do is write it as just 5x over 3z. But the 4th root of 5 is not a nice number. The 4th root of 3 is not a nice number. X divided by z doesn't simplify, so I think I'm just done.